Also, a very warm welcome from my side, and thanks to Native AI for hosting us once again. It's always great, in particular the food and the drinks. Yeah, my talk is a little bit different. So last time I was speaking about financial mathematics and ChatGPT and BART just a little bit, and I think we have come a long way, right? So it's now roughly 1.5 years that ChatGPT came out, and there have been enough in the press beyond what the tool can do in terms of corporate governance. But I want to focus indeed on the tool itself and why mathematics. I have here, right? It is in German, right, from Roger Bacon, one of the, I think, most famous quotes. Denn in jeder Wissenschaft ist nur so viel an Wahrheit enthalten, wie in ihr Mathematik steckt, right? Meaning simply, if there is no math, there can be no truth, right? The argument goes further that philosophy needs mathematics, theology needs philosophy, and then we conclude that if there's theology without math, it is not really about God anymore, right? And what you read here as well is that mathematics is closest to godly thinking, right? That one can conceive of. I wouldn't go that far, but mathematics is, of course, pretty important for basically everything. In terms of science, programming, computer science, data science, large language models themselves. So whatever you want to come up with, it is important that the math is there. And therefore, I want to show you a couple of tests that I did and a couple of use cases with regard to what ChatGPT can do, might be able to do in the future with regard to different topics. And I want to start with something very simple that people have now, and pupils, students have now their own tutor, right, that they can ask anything, and the machine can teach, and the people can learn. For me, as a teacher, as an online trainer with our company, the Python Quants, I use it as well for different purposes in the areas of teaching. Then I want to show you a couple of examples with regard to OCR, translation, and the generation of LaTeX output, solving problems. I think this is what everybody probably understands when they think of mathematics, right? Coming up with a theorem and the appropriate proof for it, right? And last but not least, this was in discussion with Klaus Schindler, who is here today, who was teaching me math here back in the old days. When did I start? 1993, when I started here with business administration. This was one of my first lectures with Klaus. So he had the idea, and he proposed to say, well, let's check whether it can basically understand visually what is going on in a graph, for example. The very first thing is about learning, and this is pretty short. The answer of ChatGPT is relatively long because I asked with regard to a comprehensive answer, etc. So that's basically the first thing here. Explain the concept of differentiation of a function in a concise way, but as comprehensive as necessary. Provide specific mathematical examples for illustration, right? And I now don't want to read the whole text. This is indeed here for illustration, right? It lists a couple of functions after the abstract concept, right? And then going a little bit further, of course, what is nice, you always get your Python code these days. I could imagine that it will come up with other interpreters and engines in the future, including the visualization. And what I noticed, because I wanted to include the links to the single chats into my slide deck, but they don't allow sharing with graphics, so I couldn't do that. Therefore, I can only show it as it is here. Of course, this code can be copied, and then I ask about differentiation, right? About integration with regard to the Riemann integral, right? And again, please provide an example based on Python, and here we get a nice visualization what a Riemann integral is about, what the basic idea is with regard to putting the x-axis into slices, etc., right? So this is just one example from a million possible ones, and basically on every level, if you like. And the code that you get, that's nice. We can see already that it's executed. If the code wouldn't execute, we wouldn't get the chart, but of course we can copy it and we can work with it. We can adjust it. Plain vanilla standard Python, I think independent of basically all the versions that you have been talking about before. Just uses matplotlib and a couple of standard stuff, and we can generate here the graphics that we have been seeing before. I think in particular for those who are learning and exploring, this is really, really nice. For sure, this wasn't available around when I needed to go through these concepts back in the old days. So for sure, at least an enrichment, I would say, right? That is one example. Learning about differentiation and integration. Again, there could be many others. Then, something like this. So I created this little piece of paper, and intentionally I did the screenshot and left a couple of the keys there, and I was saying read the integral, transform it to LaTeX, and solve the integral numerically by using the antiderivative, explain every step in detail. Right? It might be a typical task, I don't know, at a high school level. Well, my son, for example, currently is. This might be something he might be confronted with. Of course, this is a very simple thing that we see here. But nevertheless, I mean, the first thing is that it needs to, where do I have it? The cubic function into, here we go. That's the chat. It needs to scan the whole thing. Let me quickly reload that. So when you go with the things here is the screenshot, and then it says, yeah, the integral is, and then I get here the LaTeX code for the integral. Then it says what it's going to do. It does the derivation of the antiderivative, calculates the numbers and gives it here not numerically. It then uses Python to calculate values, and we get them here as well. So pretty simple, but again, you could come up with something much more complex and say, give me LaTeX code for it. I was talking to Klaus before how many hours he has been writing LaTeX in the past decades. And I myself have done a little bit. I would say my PhD thesis and many of my books have a ton of LaTeX, but this is, of course, a very easy way to get something like this done, right? Just write it down or take a picture of a blackboard or whatever, and it can read it and transform it. Now, to make it a little bit more complex, and this is driven really by a real-world discussion that we had with regard to potentially translating Klaus's book from German into English, right? And I haven't been successful in coming up with somebody who was willing to translate the whole work, right? Including the LaTeX stuff and the typesetting, right? But again, ChatGPT these days can come to the rescue. Here we have that one, right? It's just like, I would say, roughly 2/3 of that particular page in the book, linear systems of equations. I see here a ton of LaTeX and something like this. Everybody who has done it, well, we know this might take a little bit. And what I was saying here is from the attached screenshot, generate a self-contained complete LaTeX script in English that generates output whose layout is like the original. I mean, I think it's pretty clear, and he is able to do it, yeah, perfectly, right? We get here the code. The code here is, right, it's the layout code for LaTeX, and I think I have it open here. That's the real output that is generated exactly by the code that we have just been seeing here, right? It has added here a title, a header, or whatnot, right? This can, of course, be deleted if you want to have it exactly. And, of course, in typical books or articles, this is automatically numbered. But even that, ChatGPT has done here literally in terms of adding the exact numbering that was seen on the screenshot, right? And again, everybody who has done that knows that it's not that simple and straightforward, right? You need to type quite a bit in order to come up with it. On the left-hand side, we see what this involves, but it takes, I don't know, less than a minute until ChatGPT solves that particular problem, right? So that was that example, right? From a screenshot, reading it out, OCR, translation, and creation of not Python code in this case, or some other programming language, but the layout language, which is the standard in all of math and the hard sciences, right? Now we come to what I was calling before the real math, right? To prove something, to solve mathematical problems. This is from Bachelor of Science in Mathematics program. And you see here it's a pretty short one. I like it, and it's about the series here, the sum, infinite sum. And the question is for which values the sum that we see here, the infinite sum, is converging, right? And the first thing again, I was asking translate it to English and then provide a detailed solution. Let's have a look. The convergence here, it's that example. Here we see it. And then it's explaining what it's doing. It's coming up with the first interval limit, the second one. So here x smaller than 3, x greater than 1. So the series converges for these values. And then here it does it with Python again. The first thing is really reasoning, right? Mathematical reasoning. Here it uses SymPy and solves the problem with Python. Right, and here I ask a follow-up question, what about the interval limits? Because it's just giving us here the crater signs, or smaller ones, right? And then it checks here for the limit values and correctly comes up with 1 included, so semi-open interval here, and 3 excluded. So now we have the solution of this problem. So it's really math, right? And we have discussed this as well. When people say, well, this is all just probabilistic, I don't know, a prediction of words and stuff. To me, it seems there's a little bit more going on than just having a probability distribution over the next word that it should write down here. So this involves a bit more. Not always, so I'm presenting here, I would say, success cases, but I've tested it with many other similar tasks, exercises, and it works in general, but sometimes you might be surprised that it is not able to solve simple stuff. So where it obviously defaults to something more language oriented and not to the mathematical reasoning side. Right. Then we have here something which Klaus provided as well. This is about financial mathematics problem, about discounting and the transformation of a series of payments. And first task, once again, is translation in English. And then we move on. Where do we have it here? It's naming it in German, right, with a solution. I must be honest here, I haven't checked whether this really conforms with what you have been expecting back in the days. I need to compare it with your sample solution. But it understands it and it knows what to do, right? It explains what the problem is, what you need to take into account, right? What the steps are to solve it. So really what you would expect from somebody maybe in an exam, right, with regard to an exam solution, or when somebody is teaching you that in a tutorial or in a general lecture or whatnot. So I find this really, really remarkable. As you know, I started with my domain with financial mathematical financial theory, right, and it was pretty good. But I mean, if it's actually pretty good in general math, then everything else, of course, could be expected to be, at least to a large extent, be mastered by ChatGPT as well. So that's the core, I would say, typical solutions of problems, exercises, proofs. That's what I guess is really at the core of math. But there are other things, and this is what I really found interesting. So we and I a bit more have played around with problems like this. So for us, I think it's not too difficult to see that this is a cubic function, right? But again, for something like ChatGPT, a large language model, this is now what they call multimodal, right? You have not only text input and text output, you can put in now visual input, something like this, or other stuff, right? And what I was saying here is analyze the attached graph carefully and derive the generating function, derive the first and second derivatives, and plot all three in a new figure. And my header here is an educated guess, right? So I was saying, well, for us, maybe we have done this a couple of times at high school doing our studies, right? But the machine here, let us see what it's doing. That's that one. Cubic function here. And it starts already, the graph appears to represent a cubic function given its shape. So that's an educated guess, right? It has a look at it, technically, obviously, right? But it comes up with the appropriate educated guess. It doesn't say that it's just like the plain vanilla cubic function. it comes up with the general form of the cubic function. So ax to the power 3, right? B squared cx plus d. Then it says, really, however, since the exact points are not provided, we can assume a simple cubic function of the form, right, for our analysis. And then it proceeds, right, with x. This by chance now, by the educated guess, is exactly what I was feeding the machine. And it comes up here with the first derivative, with the second derivative, and does exactly what I was asking for. The plot here is now not equal scaling. That's the reason why it looks a bit stretched out, right? When you have a careful look here, with the in particular here with the second derivative, the linear function, this is driving here the unequal scaling. So educated guesses also possible, right? You load up something, and then it starts analyzing it. And last, I think, but not least, it's the same example, but I formulate the task differently, right? And the same function, and here intentionally, because I played around with it, and this increased the chances of success tremendously. I've taken away the grid, I've taken away the box, I did it in black and white, right? But it's the same function, just with 11 points now. And what I'm saying here is, or asking it to do, is determine the coordinates of the dots in the figure, that's a typo I see, based on educated guesses. So I exactly say, try not to apply any visual recognition algorithm, what it sometimes does, right, with sky image or whatever. So just based on educated guesses. And this was really surprising. But again, it took me a while to come up with that, with this black and white and no grid, blah, blah, because this was obviously leading ChatGPT on the wrong paths, right? But here, it indeed comes up with the coordinates, but it comes up with estimates, right? With what I was asking for, educated guesses, right? But the numbers here, the left and right points are exact, easy to read, because they are on the axis, right? And the others are not exact, but good enough, right? So please note that these are approximate values based on the visual information. And then, and this was my plan in the first place, right, use these dot coordinates for an ordinarily scarce regression. And now I'm saying, I mean, there's a number of things that you can use in the Python world to do OLS regression. And as I use a polyfit and plot the resulting function, including its first derivative in a new figure. So it translates it now in a Python format, right, a NumPy array object, two-dimensional, and then applies polyfit, comes here with the derivative of the polynomial, and then does exactly what it was asking it for, right? Here you see it's again, the cubic form, roughly. The estimates are not exact, right? Here we see the derivations, but this was, right, what we would do as well, probably. Polynomial fit, the first derivative, and the axis here, the crosses, are the original dots, right? And then it explains again what it is doing in here. So, with much more sophisticated functions, I haven't been so lucky, but now with the coloring, etc., it might be quite a bit better as compared to our first tries. Right, in a real world situation, you probably would have something, right, where somebody is asking you to do something, or you have found something that you want to read out. So this might not be working perfectly, but you see that it understands what you want to have it accomplished, and it does so, again, based on a pretty systematic approach, explaining what it's doing, providing Python code that you can use for other stuff, right? And these tasks, at least, I would say, it is able to solve and work on successfully. So with regard to math, I think they have done a ton of stuff. And recently, I don't know, this was a different LLM. This particularly trained model on mathematics was able to basically solve all the problems of the geometry Olympiad recently. I don't know, in recent years, which I don't know exactly which problems they took, but if you fine-tune these models, to a specific topic, to a domain, then they are much better than the general ones that you are typically using, like I here with ChatGPT 4. So a long way, but pretty, I think, pretty interesting what the machine can do already today. Yeah, this is the end. Maybe before I take questions, of course, just here a little bit of advertisement. My next book. I just received the black and white design, draft design of the cover, O'Reilly Reinforcement Learning for Finance. And this is probably coming out in summer, I would say. But it's always like the big surprise which animal they put on the cover. And I was telling the story a bunch of times. The second email I ever exchanged with O'Reilly in 2014, it was saying, no discussion about the cover. Right? The animal is decided on by the marketing department, and you just need to accept it. Basically, you have no option. But this one I really found funny, so therefore I'm quite happy with it. Just compared to some of the others that I have. So 4 O'Reilly books means my 5th animal in this regard. All right, thanks, and of course, if there are questions, I'm more than happy to take them. Yeah, Jonas?
Did you try doing a mathematical quiz with ChatGPT? Maybe even of a yet unsolved mathematical problem?
Yeah, I was thinking like asking it like what are the big problems in the future that you might be able to solve, stuff like that. But I didn't go too crazy as you have been seeing. So I tried much harder problems, some of which I myself don't have an answer to, right? Because you find a lot of stuff on the web, of course, in this regard. But I didn't try now the hardest things in the world. So I'm pretty sure that it's not yet able to prove Fermat's last theorem like Wiles did back in the days, where he was working on for 7 years full time. Right? So I wouldn't think that it's able to do that, but still, I find it impressive what is already possible. Yeah.
Somehow a philosophical question, but asking for a friend, he's a professor at a university, how should he frame his questions inside his next math lecture to the students, maybe even in an exam, so that they can't just use ChatGPT to get an answer to the maybe complex problem?
Yeah, it's difficult. Again, a topic that we have discussed. Everything that is quote unquote mechanistic, right, is probably something where ChatGPT is pretty good, right, where there's a straightforward solution. I think reasoning and recognizing relationships, this is probably something like the visual stuff. So we tried it with slightly more complicated stuff where it miserably failed, right? When you then saw the functions that it was plotting as nothing, basically nothing to do with that was what was on the screenshot, for example. But it's becoming more difficult in other disciplines as well. Just think of the legal profession. Right? You say to ChatGPT, set up a contract for whatever, right? And or ask that question here and there. So that's, I mean, what I want to say, this is plain text, right? And I think at all plain text tasks, ChatGPT is really good. So the mathematics discipline, I would guess, is still kind of prone if the exam questions are the proper ones. But again, this one task that I've had, I think it was the Aufgabe 6 one. This is really how did I call it? This was a question where you are asked in the Bachelor of Science mathematics studies to mail in tasks, right? I mean, it's up to the student, right? If the student wants to learn it or not. I mean, you get maybe your points when you ask ChatGPT, but then the exam is around the corner and you're sitting there without the machine, right? So I don't know. It will be difficult for many to resist the temptation, right? When in the old days they might have been sitting there for, I don't know, 12 hours, right? Now after 2 hours, let's have a look at ChatGPT, what ChatGPT is saying. Right? And this holds true for many, many other disciplines, I'm pretty sure. Yeah?
I know where there's an integration with Wolfram. Have you maybe tried to check how differently it performs when it's purely GPT-4 versus with the integration of Wolfram?
Yeah, the Wolfram add-on add-in is one of the few that I have really in there, but I haven't used it intensively, or I cannot comment on the differences, whether it's much better or not. So this was really here plain vanilla ChatGPT. Right. But it would be interesting, of course, because they claim to be the best in this regard. Right? Yeah.
I guess it's fun to check what ChatGPT can do on problems that you would understand yourself and where you can verify that it's indeed doing the correct thing or the wrong thing. But it's more tempting to like let it do things that you wouldn't be able to do yourself, right? But are there any mechanisms or like techniques to make sure that whatever ChatGPT comes up with that you yourself might not understand is actually kind of verifiable, so it's not too much risk?
I don't know. Just today, when I was listening to a podcast, I was asking myself, how did they do it? They claim that C3 AI, that their generative models are hallucination free. So I don't know how they get it, because even ChatGPT is still hallucinating these days and coming up with whatever, right? What it wants to write. I think this is, of course, pretty challenging, right? If you don't have a reference solution or a benchmark, right? When Klaus provided me with a set of questions, old exam questions, tasks, right? There is a solution coming with it, so you can compare. But how would you do it with anything else, right? Where you say, well, if you don't know the answer, how would you possibly? I mean, you can do reality checks or check for boundary cases, check for inconsistencies, right? But in the end, this has all limits, because if you would fully understand and you can fully verify, then you would have been in a position that you excluded in the first hand, right? Saying you are not able to solve it. But of course, I mean, if you are not able to come up with a mathematical proof, it doesn't mean that you can't fully understand what's going on, right? So in that sense, with a lot of domain expertise, I'm pretty sure you can at least nail it down and say this makes sense or not, or here this looks like a mistake. But sometimes even, I mean, when I have a look at the code that it's typing down, quote unquote typing, right? And I think this makes sense, but the code doesn't execute, right? Of course, this is in real time where you look at the code, right? So, but even I fall, or others as well, I would guess, fall into that trap and say, well, looks okay, but right, the truth is always, with the code at least, you have the truth, whether it's executing or not. So you have a binary situation, fortunately. Yeah.
Was there any case where you saw the mathematical reasoning not happening, or which couldn't be learned, and it was able to prove it that in a logical sense that this was happening? Or was it simply that these are available online on the text database or corpus where it could be learned?
I mean, first and foremost, I would say that one of the major skills of ChatGPT is to have all the output look reasonable. This is what hallucination. I mean, hallucination doesn't mean that the text doesn't make any sense, for example, right? Or the math. So I cannot now pinpoint to something where I would say, well, this looks nice, but after more deeper inspection, right, I figured out that it wasn't the case, that it was correct. Um, of course, I have asked it a couple of math questions where it simply wasn't able to come up with anything reasonable. So, but I didn't present these cases. I think they are not so interesting. But of course, it's there. I'm not saying you have 6 success cases, and the other 6,000 that I might be trying, right, will be solved in the same satisfactory way, right? Probably not. And pretty sure that's just the beginning, right? If it's now, today, at this state, so 1 year ahead in the future and 5 years ahead, it will be much, much, much better, right?
Did you by any chance had any go through like how the mathematical processing, if it is not contextual learning, then how exactly the behind scenes could be done, or any blog or any papers that
I don't know. So I'm asking this myself with regard to the text and transformers and probabilistic prediction of the next words or word snippets. I think this is quite easy to understand by everybody, but how it exactly does it here with the mathematical functions, probably in a same or a similar way, right? These are simply other tokens, right? The mathematical tokens, we could say, and might have something similar going on, but honestly and frankly, I don't know whether there's really some reasoning going on or whether it's indeed plain vanilla probabilistic prediction of the next term that it's using or whatnot, right? But it seems to recognize, I mean, only the visual thing, this looks like a cubic function. I mean, this alone, right? It probably has seen enough cubic functions to somehow has, right, the classification problem included in everything that it does. But still, you load up bits, right, a bitmap, and it's able to recognize what's going on there, even to come up with the educated guesses of the coordinates of all the sample dots in that chart, right? And more, right? This is really interesting, I think.
Just a recommendation. A colleague of mine told me that he wants to take a course on prompt engineering, and I thought, prompt engineering, well, that sounds like black magic. The course is held by Andrew Ng, so quite a famous professor in artificial intelligence.
Absolutely.
And I was quite surprised about the content because some of the patterns were really, they make sense. So if you want to get a nice intuition how to potentially phrase your problem and get a better answer, I think this course could be beneficial to have a look at. With something like asking first for the description and then for the conclusion. So you somehow force the network to look at its own context that it already produced to come to a better solution. And there are small little tricks in this course which I found helpful, and then I understood that it's not just black magic, that prompt engineering is really a topic nowadays.
Is it on YouTube? Is it a free course?
And on Coursera it's free.
Coursera free, prompt engineering, Andrew Ng. Yeah,
Nice tip.
good recommendation. Thank you.